Good day, class. I am Alea Don Isoberano, your student teacher for today. In our previous lesson, we have talked about behaviors of light. And today we are going to discuss about one specific behavior of light using one specific medium. And we're going to find that out in this short activity. In this activity, I'm going to show you a picture and I want you to share the first word that you think or the words that you think of after seeing the picture. So here's the picture. So class, what words do you think of after seeing the picture? So if you thought about mirrors, reflection, image, or clear, then your answers are right. Do you now have an idea what our lesson for today is? Our lesson for today is reflection on mirrors. First, let us define what are mirrors. A mirror is an object that reflects an image. One example of this is when we use mirror to see ourselves. And these are the images that is reflected by the mirror. A mirror is a wave reflector. One example of this is through light. So we all know that light travels in the form of waves. Once it approaches a surface, such as mirror, it is then reflected by the mirror. So let's have a vocabulary related to reflection so we can understand the reflection on different type of mirrors that we are going to discuss on the next slides. So first, let's define reflection. Reflection is the bouncing off of light rays as it hits a surface such as mirrors. So, as you can see in the GIF, the light coming from the flashlight approaches the mirror and then bounces off, and that is what we call reflection. Let's define light rays. Light rays are an idealized model of light, which is drawn as a straight line. There are two types of light rays. Number one, the incident ray. The ray of light approaching the mirror represented by an arrow approaching an optical element like mirrors. So you can see in our GIF, the incident ray is represented by the blue line. Another ray is the reflected ray. The ray of light which leaves the mirror and is represented by an arrow pointing away from the mirror. So you can see the red line is represented by the reflected ray. The normal line, represented by the breaking lines in the middle of the two light rays, are imaginary line that can be drawn perpendicular to the surface of the mirror at the point of incidence where the ray strikes the mirror. The angle of incidence versus the angle of reflection. The angle of incidence is the angle between the incident ray and the normal line. On the other hand, the angle of reflection is the angle between the reflected light and the normal line. So according to the law of reflection, the normal line, incident ray, and reflected ray lie on the same plane. It also states that the angle of incidence is equal to the angle of reflection as long as the surface is smooth and even, just like mirrors. So this law of reflection only applies to plane mirrors, where it has smooth surfaces. Let's apply what you have learned in the law of reflection by having this sample problem. What is the angle of reflection if the angle of incidence is equal to 40 degrees? You may share your answer on the comment section below. If your answer is 40 degrees, then you are right, because the angle of reflection is always equal to the angle of incidence, applying the law of reflection. Reflection can happen not only on smooth surfaces but also on rough surface. In fact, there are two types of reflections. Number one is specular. These are reflection of light rays on smooth surfaces such as mirrors or a calm body of water. Because of smooth surface, angle of incidence is always equal to the angle of reflected rays, giving a clear image of an object. Another type of reflection is the diffused reflection, which are reflection of light rays on rough surfaces, such as wavy water or the asphalt broadways. In diffused reflection, the surface is uneven, so the angle of the incident ray is not equal to the angle of reflected ray, which gives blurry images. So as you can see on our picture, the specular reflection shows equal angle of incidence and angle of reflection. On the other hand, in diffuse, the angle of reflection is not equal to the angle of incidence. Let's have these two pictures to compare the images formed in specular reflection and diffused reflection. So in the first image, you can see that there are clear images of trees reflected by the calm body of water. On the other hand, you can see in the diffused reflection, the trees reflected by the wavy surface of the water causes the image to form distorted or wavy as well. Let's proceed on the types of mirrors. There are two types of mirrors. Number one is the plane mirror. It is a mirror with a flat planar reflected surface. One example of this is the mirror that we use at home, which is shown in the picture. Another type of mirror is the spherical mirrors or curved mirrors, which is divided into two types, the concave mirror and the convex mirrors. A concave mirror is a curved mirror in which the reflective surface bulges away from the light source. It is called converging mirror because the parallel incident rays converge or meet at a focal point after reflection. Convex mirror is a curved mirror in which the reflected surface bulges towards the light source. It is called diverging mirror because the parallel incident rays diverge after reflection. When extending the reflected rays behind the mirror, the rays converge at the focus behind the mirror. So one great example of spherical mirrors is a spoon. It composes of concave and convex mirror. There are two types of images formed by mirrors. Number one is virtual images. It occurs where rays only appear to diverge. It is always upright and appears behind the mirror. Another one is the real images. It occurs when reflected rays converge in front of the mirror. It is always inverted or upside down, and the image appears in front of the mirror. So as you can see in the picture, using a spoon which has both convex and concave type of mirror, when we use the concave, a real image appears because it is inverted. On the convex sides, it produces a virtual image because the image is always upright. There are methods used in describing the images formed by curved mirrors. One method is called the graphical method or ray diagramming. So you can see in the GIF, that is an example of a graphical method. So in graphical method, there are three important points that are considered as shown in the figure. The number one is the center of curvature, which is denoted by capital C, the center of the sphere of which the mirror is part. Its distance from the mirror is known as the radius. The next important point is the vertex, denoted by capital letter V. This is the center of the curved mirror. The next point is the focal point or focus, denoted by capital F. This is the point between the center of the curvature and the vertex. Its distance from the mirror is the focal length, denoted by small letter f. So you can see in the picture, there's the graphical method composing the important points. The principal axis is the straight line that composes the three important points that I have mentioned earlier. So the center of curvature is on the left side of your screen, and the focus is between the center of curvature and the vertex. The vertex is the center of the curved mirror. So there are four principal rays in curved mirrors. Number one is the PF ray. Second is the FP ray. Third is the CC ray. And fourth is the V ray, where P is for parallel ray, F is for focus or focal point, C is for the center of curvature, and V is for the vertex. Take note that you need at least two of these rays to describe the images formed by convex mirrors or concave mirrors. Let's have the PF ray in concave and convex mirror. In concave mirror, a ray of light parallel to the principal axis is reflected through the focal point or focus. On a convex mirror, a ray of light parallel to the principal axis is reflected as if passing through the focal point or focus. As you can see in the picture, there is an imaginary extension of the reflected ray that points through the focus. On the FP ray, in concave mirror, a ray of light passing through the focal point or focus is reflected parallel to the principal axis. On a convex mirror, a ray of light directed towards the virtual focal point or focus is reflected parallel to the principal axis. You can see in the picture there is also an imaginary line extension of the reflected ray. On a CC ray, in a concave mirror, a ray of light passing through the center of curvature reflects back along its own path. On the convex mirror, a ray of light directed towards the center of curvature reflects back along on its own path. As you can see, the imaginary extension of the reflected ray passes through the curvature. On the V ray, in concave mirror, a ray of light directed to the vertex reflects at equal angle from the principal axis. On a V ray in convex mirror, a ray of light directed towards the vertex reflects at equal angle from the principal axis. As you can see, there is also an imaginary extension of the reflected ray. In V ray, principal ray, the law of reflection is applied where the angle of incidence is equal to the angle of reflection. Let's now have the rules in ray diagramming or graphical method in concave mirrors. Please make sure that you already have the principal axis consisting the three important points together with the object in the curved mirror. So rule number 1. Draw a ray starting from the top of the object parallel to the principal axis and then through F after reflection. Rule number 2. Draw a ray starting from the top of the object through the focal point then parallel to the principal axis after reflection. Rule number 3. Draw a ray starting from the top of the object through C then back upon itself. So what do you notice about the three lines? At some point, they intersect. This intersection is the location of the image. So after getting the intersection, draw an arrow down from the principal axis to the point of intersection. Then answer the following questions. Is the image on the same or opposite side of the mirror as the object? Is the image enlarged or reduced? Is the image inverted or right side up? So for number 1, the image is on the same side of the mirror. The next one, the image is reduced. And the third one, the image is inverted. Therefore, it is a real image. The characteristics of the image depends on the location of the object in the curved mirror. And in this case, we are going to identify the characteristic of the image when the object is at the center of curvature. So, there are 4 important points to describe the characteristic of the image. And it has an acronym of LOST, which is spelled as LOST. L stands for location of the image. Is it in front of the mirror or behind the mirror? O stands for the orientation of the image. Is it upright or inverted? S stands for the size of the image. Is it enlarged, reduced, or the same? And T stands for the type of image. Is it a real image or a virtual image? So in this case, when the object is at C, let us find out the 4 important points of describing the characteristic of the image. So for L, the object is, or the image is in front of the mirror. For O, it is inverted. The size is the same and the type of image is real since it's inverted. Let's have the next case, when the object is between C and F. What do you think will be the images formed? So you can take this slide to answer on your paper. The next one is case number 4, object at F. So you will notice that there is no intersection. So what do you think is the image form? In this case, there is no image form because there is no reflection. Therefore, we cannot answer the 4 different points in describing the image. The next one is when the object is between F and V. So you can also have this slide and answer it on your paper. Let's now have the rules in ray diagramming or graphical method in convex mirror. First, let's pick a point on the top of the object and draw 2 incident rays traveling towards the mirror. So as you can see in the picture, we have 2 incident rays. One is parallel to the principal axis and one is pointing to the focus. Next is, once these incident rays strike the mirror, reflect them according to the 2 rules of reflection for convex mirrors. So you can go back to what we have discussed regarding the reflected rays on FP rays and PF rays in convex mirrors. Next one is locate and mark the image of the top of the object. So you can do this by extending the lines of the reflected rays, and that intersection will tell us the point of the image. So in convex mirror, always remember that the object is behind the mirror, the orientation is always upright, the size is smaller, and the type of image is virtual. Another way to describe the objects or the images formed in curved mirrors is through the magnification equation, which is denoted by m is equal to height of the image over the height of the object, or equal to the negative distance of the image over the distance of the object. So here is how this works. So once we apply this equation, if we get a positive magnification, the image is upright. If we get a negative magnification, the image is inverted. If the magnification value is greater than 1, the image is enlarged. If the magnification value is less than 1, the image is reduced. If the magnification value is equal to 1, the image is the same as the object. So let's have this problem. Calculate the magnification of the image formed by a concave mirror if the height of the candle is 8 cm and the image height is 6 cm. Indicate the type, orientation, and size of the image. So please rely on the equation that I've given earlier, and you can also answer this on your paper or your on the notebook, big notebook. So if you have question, you can ask me for clarifications. So that's all for today, class. Thank you for listening. Again, good day.